Success Clinic, and remember, good success is always achievable. So today on Simplified Physics, we are still on SS1 first term curriculum. So our topic, so today is the third lecture. So our topic is what? Measurement 2. So a continuation of the last lecture. So what are we going to be discussing about? So the course outline is what? We have measurement of length, measurement of mass, measurement of weight, measurement of time, and measuring instruments. So those are the things we are going to be focusing on today. So let's go to the first one, measurement of length. So how do we measure length? So we say that length is what? The distance between 2 points. Length is measured using the following instruments. So if we want to take measurement of the physical quantity length, we do that with any of these instruments. We have meter rule, we have caliper, we have vernier caliper, we have micrometer, screw gauge. So let's talk about individual of them. Meter rule. So the meter rule is an instrument used to measure lengths and distances. It is calibrated in centimeters with a range of 0 to 100 cm. Now if you notice, when we say meter rule means that the length of the rule is actually what? 1 meter. And 1 meter, when you convert 1 meter to centimeter, it will be what? 100 centimeters. So a meter rule ranges from 0 to what? 100 centimeter. Now whenever we are using our meter rule, we have to be careful, because if we want to take reading for the meter rule, we have to avoid what is called error due to parallax. What error due to parallax means is that you have to look directly under the meter rule to get the accurate reading, not that you'll be looking at it from the side. Now the smallest reading that can be obtained on the meter rule is 0.1 centimeter, which is actually what? 1 millimeter. So that is the smallest reading we can get on what? A meter rule. So this is a sample of how a portion of a meter rule looks like. So let's go to the next one, which is the caliper. Calipers are used to measure distance on solid objects where an ordinary meter rule cannot be applied directly. So there are sometimes it is hard for you to measure directly with meter rule. For example, you want to measure a cylinder. It is hard for you to measure the diameter of a cylinder just like that with meter rule. So we make use of caliper. Caliper have steel jaws which are used for measurement. So the distance between the jaws are then measured using the meter rule. So we have three types of caliper. We have the external caliper, which is used for what? External diameter. We have the internal caliper, which is used for internal diameters. We have the odd leg caliper. So odd leg caliper is used basically to obtain the center of a spherical or of a cylindrical object. So these are the calipers that we have. So the one by the right is what? The odd leg caliper. Next to it is the outside or external caliper, and then the last one is what? The internal caliper. So the odd leg caliper, external caliper, and internal caliper. Okay, vernier caliper. This can measure length more accurately than the meter rule. So these ones are used for more accurate measurement. So, and their own, not just like the meter rule. The smallest accuracy that a meter rule can have is what? 1 millimeter, which is 0.1 centimeter. The vernier caliper can measure up to 0.1 millimeter. So you can use the vernier caliper to measure things like the thickness of a meter rule. You can use it to measure things like external and internal diameter of a test tube. You can use it to measure the diameter of a rod. So all these things can be done with what? Vernier caliper. So for the vernier caliper have set of 2 jaws and what? 2 scales. So look at the picture of the vernier caliper. You can see we have the internal jaws. These internal jaws are behaving the same way as the internal calipers. So they are used for measuring internal diameters. We have the external jaws here. So this one is used for what? External diameter. We have the locking screw. Locking screw is to lock the reading. Lock the reading on the scale. Now this one here is actually the vernier scale, the one that the locking screw is connected to. While this other one, this bigger one, this longer one is what? The main scale. Now look at this last part here. This part, let's go back. This part is actually used for what? Measuring depth. So the vernier caliper can actually be used for three measurements: the external diameter, the internal diameter, and depths. So those are the three things a vernier caliper can be used for. So let's go to the micrometer screw gauge. Micrometer screw gauge measures smaller lengths. So these ones are for very small things, like the diameter of a wire, the thickness of a paper. So these ones now, vernier caliper, it will be difficult for vernier caliper to measure those small lengths, and the micrometer screw gauge have higher reading accuracy because it can measure up to 0.01 millimeter. The meter rule can measure 0.1 centimeter, that is 1 millimeter. The vernier caliper can measure 0.1 millimeter, while the micrometer screw gauge can measure up to 0.01 millimeter. So you can see that it's used for measuring diameter of small balls. Like you look at the ball in ball bearings, pendulum ball. So the micrometer screw gauge is used for very small measurements to give us accurate reading. So this is a picture of what the micrometer screw gauge look like. So it has two scales to it. It has the main scale and it has the what? Micrometer screw scale, which is the circular scale. So we have the anvil and the spindle. So in between that anvil and spindle is where the material we want to measure will be placed in, and using the ratchet the spindle is made to tighten the object. So let's go to measurement of mass. How do we measure mass? Now, what is mass? Mass is what? The quantity of matter a body contains. So when we say mass of a body, we are asking ourselves, how much matter does this body contain? So mass is usually measured by comparing it with standard masses using a balance. Now there are various instruments we use to measure mass. We have the beam or chemical balance, we have lever balance, dial balance, direct reading balance, we have triple beam balance, and so many balance, etc. So look at this one now. You can see the different examples of balances we have. So this one is beam balance, this one is triple beam balance, and the other one is lever balance. So those are a few examples of what instruments used for measuring what? Masses. So let's talk about measurement of weight. Is there a difference between weight and mass? Yes, there is. So what is weight? Weight is the amount of gravitational force acting on a body, or the force which a body is attracted towards the center of the earth. The weight of a substance varies from place to place due to variation in acceleration due to gravity over places, but mass remains constant from place to place. So the instrument that we use for measuring weight is called the spring balance, and mind you, weight is measured in Newton. Like based on mathematical expression, weight is actually mass times gravity. So this is example of our spring balances. So what are the differences between mass and weight? We say they are different. We should notice some of them. So number one, mass is what? The quantity of matter present in a body, while weight occurs due to the force of gravity acting on an object. Mass is constant. Wherever you go to the next planet, you go outside the space, you go to different countries, the mass of a body remains constant, but the weight of that body changes. It depends on what? Gravity. Mass is a scalar quantity, while weight is what? A vector quantity. We are going to discuss about scalar and vector in few chapters to come. So scalar quantity is basically those quantities that have magnitude but no direction, while vector quantities are those ones that have both magnitude and direction. The unit of mass is kilogram. The unit of weight is what? Newton. Mass is measured by chemical or beam balance, while weight is measured by what? Spring balance. The principle of moment is applied to obtain masses. The instrument used for measuring weight obey Hooke's law. Now another thing we should also note, which is not here, we should also note that what? Mass is what? A fundamental quantity, while weight is what? A derived quantity. So these are the what? Differences between mass and what? Weight. So let's go to measurement of time. What is time? Time is what? The interval between two successive events. The interval between two successive events. Time is a fundamental quantity and it is measured in what? Seconds. So the major instrument we use for measuring time in the lab is what we call the stopwatch. But although we have other instruments like water clock, hourglass, sand clock, sundial, wristwatch, pendulum, wall clock, etc. So this is a picture of some instruments that we use for measuring what? Time. So the first one there is actually what? Is actually the hourglass. The next one is what? Water clock. The next one is what? The sundial. The next one is what? Wrist is the pendulum clock. And the last one there is our what? The last one there is our what? Stopwatch. Okay. So measuring instruments, we have other measuring instruments. So measuring instruments are tools or devices used in field of science to get exact measurement of objects. The measuring instruments help us to get the exact dimension of physical parameters. Examples of measuring instruments. Time, we have things like pendulum clock, hourglass, stopwatch, ticker, tape, timer. While for mass, as we have said, we have lever, balance, we have chemical balance, beam balance, etc. For length, we have the ruler. This we know ruler. We have meter rule, we have tape rule, we have vernier caliper, we have micrometer, screw gauge, we have calipers, etc. Now for volumes like volumes of liquid, volumes of solid, we have beaker, we have measuring cylinder, we have burette, we have pipette. For air pressure, the pressure of the air or atmosphere, we have barometer. For us to get the accurate measurement of temperature, we make use of the instrument called what? Thermometer. For us to measure weight, we make use of what? Spring balance. For us to measure speed, we make use of what? Speedometer. Okay. Now we have other things. Okay, that is good. For current, we have ammeter. For voltage, we have voltmeter. Resistance, we have ohmmeter. Electric power, wattmeter. Diameter of a thin wire or thickness of a paper, we have micrometer, screw gauge. Relative humidity, we have hygrometer. Relative density, we have hydrometer. So these are a few examples of what measuring instruments that we make use of in what? Physics. Okay, how do we read a vernier caliper? Because it's one thing to know that vernier caliper is used for reading length, but it is different from the meter rule. Meter rule is just direct reading. Vernier caliper has two scales, so we have the main scales and the vernier scales. So how do we do that? So in reading a vernier caliper, we have to check the whole number before the decimal point. The first digits after the decimal point are read from the main scale, while the second digits after the decimal point are read from the what? Vernier scale. So we are going to do an example so that you'll be able to see it. This is the point that mark that coincide with that of the main scale. Now this is the vernier caliper. Now look at the way it's trying to get the diameter of that board here. Now what happens is that if you notice we have the two scales, the main scale and the sliding scale, which is the vernier scale. Now what happens is that we are now going to check. Now you see that for this scale you see a A is the beginning of the what? Vernier scale. You see that for this place we have 5.5, 5.6. So this is 5.6, 5.6, because this is 5, 5.1, 5.2, 5.3, 5.4, 5.5, 5.6. So 5.6 is the value on the main scale before the beginning of the what? Vernier scale. Now, so we are now, so the reading on the main scale, we are going to say the reading of the main scale is what? 5.6. Now we are now going to add it with the reading on the vernier scale. So how do we get the vernier scale? Now the vernier scale, we are going to look at where both the calibration on of the main scale intersects or coincides with the reading on the vernier scale. So it happened here. So this is now what? 4.2. So we are going to add those two things together. So that is what is going to give us our what? Reading. So let's get a good example. So example 1, what is the reading of this scale? Now looking of the main scale, before the main scale the vernier scale started, it started after, so that is 4.123, that is 4.3. Now it now coincides on what? 7, that is 0.07. So that is point of coincidence. So we're now going to add the two together. So that is now going to give us what? 4.37. Okay, how do we read a micrometer screw gauge? So micrometer screw gauge, we have the main scale and the circular scale, which is the thimble. Let's get the reading. Now look at this. The main scale is somewhat here. Please. How to read a micrometer screw gauge? So to read a micrometer screw gauge, we need to combine the readings of the main scale and the what? Circular scale. So the main scale shows the main millimeter and half millimeter marking, while the one on the circular thimble scale shows 100 of millimeters. So first we read the largest hole or half millimeter marking on the sieve that is visible before the thimble zero mark. So after that, what we will now do is we will now note that, then go to the thimble marking that aligns with the reference line on the sieve. So then we now add these two together. So adding these two together, now if you look at what we have here, you see that we have 15, this place 15. Now we now have 15.5. So 15.5. Then so the main scale reading here is 15.5. Now we now come to the thimble reading, which is the circular reading. We look for where aligns, which of these align with this center line of the main scale. So what aligns to this place? You see this is 10, 11, 12, 13. So this should be around 13. So that is to say, if we now want to get the reading of this, we will say 15.5 plus 13. So that is going to give us 15.63. Okay, so let's go to an example under this. So what is the reading on the scale? This is a scale now. Now you look at this, we see 15 millimeter, 16 millimeter, 17 millimeter. So the reading here is going to be 17.11. Okay, so that is it. The line that align with the line of reference is after that 10 on the circular this thing scale. Okay, so this is an exercise for us to try out. So thank you very much for having a wonderful time with us. So mind you, subscribe to our channel, and we'd love to see you again and again and again in the next lecture. Thank you for listening. Bye bye.